Hi, today we are going to talk about initializing a game, so bootstrapping it. What I mean is that when we are in a game, typically we are playing some level, right? So let's say this is level 1, okay? And we have a certain number of objects that constitutes the architecture of that level. Now, obviously, this is specific to the level, right? So, for instance, if main is, level 1, then this is the architecture of the level for level 1. And if I finish level 1 as the player and I progress to level 2, I expect that maybe some of the same objects will be there, but maybe in different positions than they are in level 1, because simply the level is different. So, these are details that are level specific. But at the same time, there are probably going to be some game objects that we want to have all the time. If you have 10 levels, all 10 levels have, for instance, the main avatar, maybe the HUD that shows the score, the number of bullets left, the energy left of the main character, the sound manager, something that manages the cursor on the screen, right? Whether it is on and off, and all sorts of things that are essentially always there, gonna be always there. Maybe we don't want to add them together with the architecture to every level, right? Because if you have 10 levels, we have to have some kinds of object added to each one, and then if it changes, it's a little more bothersome to update it everywhere. Sure, we could use a prefab, but still conceptually, we have this problem that this object is duplicated in a sense. And that means when we go from level 1 to level 2, it gets destroyed and then restarted and recreated, And this could be a problem, for instance, if one of the objects are meant to be a bit more persistent, for instance, the one that keeps track of the score or the inventory, or how much life energy we have left. We probably would like to maintain that information from going from level 1 to level 2 and so on. And so what we are trying to achieve is, first of all, don't repeat the same objects again and again everywhere. Just have it, in a sense, done once and for all. And then also have it more persistent, because certain servers, certain managers, like the score manager and the achievement manager, and maybe there is a server that keeps track of multiplayer, All of these things are always going to be there. Basically, irrespective of which level it is, you want them. Now, there are several techniques that one can find on various sources, from official Unity documentations to tutorials, forums, and so on. But one that I found really appealing is the one I'm going to show you today. And it has several advantages. I tell you immediately, without even showing you the code, but just conceptually, right? Many people, myself included, my very first game, what I did, I made a class called globals. For instance, I needed some global variables like the score, the energy, and I made all the data members static. Now and then I made an object here that has that component that is static with all the static data. And the problem is that the static data doesn't show in the inspector, for instance. So it works. And you can say, this data is also don't destroy. So every level you go, you always have it, doesn't die. And is persistent, and it is also guaranteed to be created before anything else, because static objects are initialized before even the first object runs the first awake. If you remember from previous lessons, awake is the first function that is executed. You don't need to, in a sense, initialize static objects with a function. You can just say this integer is equal 7, for instance, right? And because it's static, and it does that. So by the time any function runs, you know that field has been initialized, and so you can use it. That's the whole point, right? It's initialized, so it's good. So we would like, though, to have it all. So we would like to have an object here in the hierarchy that when we click on it, all the fields, all of them, are present in the inspector. And like in Unity, normally, you can change them, you can see them, you can change them. Even when you play, you can change them. Then if you press again, they go back so that you get to experiment. It would be really nice to be able to do that because it's easy to debug. I mean, by experience, I can tell you that game I made eventually turned out fine, but it was a bit of more of a guessing game what values the various static data members had. You had to constantly log them on the console to know, whereas it's so much easier to just look at the inspector. Now, sometimes you still have to log them anyway because maybe they change fast, and you cannot just look at the inspector and expect to be able to tell the difference between one frame and the next. Absolutely. But so often is just it works. It's just convenient, and it gives you a sense of of knowing what the game is doing in a sense. So this is how it works this way. Let me show you. It is all about this property. It is a bit of a mouthful, so it's called runtime initialize on load method, and then particularly has to be of the kind runtime initialize load type before sync load. Now this is the key, right? Before sync load. So what is this all about? Well, we have a regular class. Now I said it's sealed. It just means it cannot be derived from. You could also remove it, it will be okay. It's good to have it because probably you don't want to derive from it, but hey, it would work also without. So if you don't know what it is, ignore it. But essentially means you cannot derive from it. Now, this is a regular class. Notice it's a mono behavior, so it's a component. You can, and in fact we do, use it as a component in an actual object. Let me show you. Here, let me drag and drop this, and there you go, main. See, has underscore main. When I double click, it takes me back here. That is where we were looking at. So it's a regular component, it shows in the inspector, it's beautiful. And see, I can make it static, just fine, this method, load main. So what does it mean? This code runs before the scene is even loaded. So why is it important? Well, for instance, because if I place this component, right, is a component because it derives from mono behavior, on a game object, that entire game object will be created before any other object are even spawned, before any awake is even executed, and then on enabled, and then start the drill. But this function is executed first. So this gives us an opportunity to do things, to set up things that is amazing, and without having to lose the transparency of being able to see things in the inspector. Now, in particular here, I have tried to really push this idea even beyond what I found on internet forums, and I just try to make it work well in practice, right? So what is it that I'm trying to achieve? Well, let's see how the technique is supposed to be used, right? So the technique is supposed to have this object that we want to instantiate before anything in any level is ever even spawned, is ever even created, any scene is created. This object, and you're supposed to put it in a file folder called resources. In this case, because I can also drag and drop it, this is my version, my addition, right? You can also drag and drop it manually. Then it is also a prefab. So it's a prefab folder, and inside the resources. Resources, as long as it's spelled exactly resources, it's fine. And then you can put all the objects you want in it. And what you get is to be able to call this function, resources load, and then you specify the name. as you can see, the name is underscore main. So any object that is in a folder called resources with capital R, plural, okay, exactly that, you can load them. It's like you can get a reference to them, okay? So that's what you do. And once you have a reference to them, right, so you check that it's not null, in which case you say error or a return, but usually if you haven't forgotten to create underscore main inside resources, it won't be null. And then you say, well, if it is disabled, log this warning. This is just me adding as a way to know why it doesn't work, right? Maybe because I disabled it by mistake. What I mean is, I literally, by mistake in here, I disabled it, right? Now, I say is a warning and not an error because who knows, maybe you want to do that. Maybe you want it to be disabled. I cannot imagine why. Maybe you have more than one object that has this feature and all but one are disabled, maybe. So because usually I expect it to be probably an error, I log this warning, but I'm not returning, I'm not saying error, I'm not returning, everything continues. And then it instantiates it. So basically what happens is that when you press play, because this function runs first, it gets a reference from resources and then instantiates it. And then it also changes its name. But before, to understand why we change the name, let's remove the part that changes the name, and let's see what happens if we don't change the name. And so nothing's in here, right? Everything, we press play. Now we see that automatically this will appear in here. There you go, main is there. You see? That's because this function was executed. And the reason is that it had this property, okay? So it found the reference to main and then instantiated it. But notice one thing. The name is not main in the hierarchy. Is main parenthesis clone. That's because we are creating it with this instantiate function, right? So when you instantiate something this way, it doesn't create, let's say you are instantiating underscore main. It doesn't create underscore main, it creates underscore main clone, okay? So, as I said, the way I modify the code, in particular this part that I added in Awake, is such that you can just, press play and have it automatically spawn, and that is actually the way it is supposed to be used still. But the thing is, as you can see, this object, when I click on it, in the inspector I can see all of its components, but none of its children. That's the way the project tab works, right? So what if I wanted to, work with it and maybe add some children, remove some children, modify some data that is in the children? I cannot do it from here. So unavoidably, in a sense, I have to do this, right? I want to test this level and I want to experiment with it, and I want to access also the children. Maybe change something in here, right? So I have to drag and drop it. So this is not something that, if you look online, nobody seems to have thought about it, but you really need to be able to do this to be able to modify it. So let's say you modify it and you find, as usual, you press play, you modify the fields, and then you realize, oh, that's good, right? What you do is this. You click on main, and then you go here in the inspector, you say overrides, apply all. So whatever changes you made, now they are reflected in the prefab that is in resources in the project tab. So you are not losing them. And the way you don't lose them is by drag and drop it first, experimenting with various values. Once you are satisfied, you select main, underscore main, and the override, you say apply all. And And then now you have it. So now you can go back to deleting it and pressing play. And now when he spawns with all the new changes that you made. So what happens if it is already in there? Won't that function spawn a second one? Well, yeah, kind of. Let me show you. See, when you get into this function, it will spawn it. And because it is executed before anything, the other one, the one that is drag and dropped, is not visible. So even if you were making a find, you wouldn't find it. Because literally this code is executed before anything in the scene is there. But here is the kicker. In awake, we can detect that. And because the one we instantiate and or the one that we drag and drop both execute awake, because I have this public static integer initialized with 0 called number of awake executions, and they both will end up doing ++, right? So I know that if I reach level 2, that means one was drag and dropped, and the other one is the one that was instantiated automatically. So I want to remove the one that was instantiated automatically, because if I drag and drop a version manually from the project tab into the inspector, I drag and drop it manually because I want to use that one, right? So I cannot avoid that it is instantiated, but I can remove it. Because you see, I still have the reference, we still have the reference because it's not a local variable of this function load main, is part of the class. So we still have it, so we say destroy it. So I print a little log saying eliminating instances of clone resources and destroy. And I think Unity also complains about the fact that there are two event systems, but is innocuous. It's simply, I guess, because in main there is a HUD. So because the HUD, and also event system, you see. So because basically you have the one I drag and drop plus the one that spawns, each has an event system. So Unity complains that even though you don't see the other one because it gets killed at the wake time, see it's not here. The only main is this one. But he said for an instance there are two, right? So it's just completely okay, it doesn't hurt anybody. And then you see it says, hey, I'm eliminating the copy _ main. So now you understand why we are changing the name from _main clone to simply _main, removing in a sense the clone part, right? Because this way, whether it is the one we instantiate or the one we drag and drop, they're both called simply _main without the clone. And that means that any code we write that depends on _main being there, we can refer to it simply as _main, because they both, no matter which code path we get there, it's always called _main, okay? And that's it. That's basically the big idea, to have a way to instantiate something before anything is ever appearing, either. And if I need to modify anything in it, because you see there are so many things, right? Including, for instance, the main character. The avatar obviously is part of it. And the HUD and the, see, if I press play, there is crosshairs, right? So, as you can see, the crosshairs become enabled and disabled depending on whether I'm aiming at something or shooting at something, right? So in this case, it's the crosshair red hit because I'm hitting something. Or in this case, it's the crosshair red hot plus the crosshair white chip, because see, I have two now. So, maybe I want to modify it, maybe I want to change the name, some characteristics. Once I'm done, I select main, I go to override, apply all, and now I can delete it. My mission is over. Now when I press play again, whatever changes I made are in this version that is the prefab, and now it gets spawned automatically, and again, I have it all. Plus, notice the last bit. That is important, of course. here, after we get the reference to main, and then we make sure this is active and so on, and we instantiate it, and we change the name, we mark it as don't destroy on load. This is the thing that makes it persist across levels, right? So if, for instance, one of the things that we have, either as a component directly in underscore main, or a component inside one of the children underscore main, is, I don't know, the score counter, the score is preserved across invocations. And that's all. That's actually all very simple when it comes down to it. Is really not rocket science, but is very, very convenient to have a way to have something that happens before anything is present, and you initialize it, and you put anything that you may need, and then any object that you create in any level, they can perform a find or try to use maybe the public functions of those objects, knowing that they are for sure there. So that's really important and simplify things so much. And so I wanted to share this discovery that I made actually in 2022. So it's kind of fresh also for me. Thank you. I hope you like that.